Okay, let us discuss this problem. So we have already said in the class, if you have an alkene and you want to add chlorine, so that is the, if you have alkene and if you add chlorine, this addition always happens trans. That is, one chlorine goes inside, another chlorine goes upside. And this happens through the cyclic halogen ion intermediate. This all things we have already discussed in the class. In the first case you have a halogen ion, in this case chloronium ion you can say, and the next step, this Cl minus, the next Cl minus can attack from the back side. So this attacks from the back side, so I will have one Cl this side, another Cl this side, so I will have a trans product. Are you getting? So this we have discussed in the class. Now this question is something unusual, so there is not a trans addition. So let us say the compound is given. I can write here. Are you able to see? Yeah, I have this compound, and if I add chlorine on this compound in the CCl4 solution, I get one product in which both chlorine is cis side, that is, let us say this Cl is downside, and here also I have Cl, that is downside, and here I have pH, here I have hydrogen, both are upside. Now I have another product. In this case the top Cl is upside and this Cl pH is inside. You are getting? And now here we have chlorine that is inside, and here I have hydrogen that is upside. Now see what is the happening. First listen and then you write. What is happening here? Cl and Cl, both Cl are upside. So this Cl and this Cl is upside. So this is, I can say both Cl are cis. But if you see here, what is happening? This Cl is downside, upside. So this is trans. So in terms of Cl, this is a trans. This is cis. Now the question is asking, discuss the mechanism for this reaction, how this is happening. If I consider this kind of mechanism which we have discussed in the top part, I should get always trans product. Cl should be always at a trans. But in this case you see, some product that is gives you the cis product, some also gives you trans product. So how can you justify this? This means attack is happening in this case either from top or from bottom, both sides. So this means I can say attack is happening from this side as well as this side. Are you getting? So attack is happening from both sides. So in this case you can say attack is happening from both sides. Both side attack we have. You have attack from top side, you also have attack from the bottom side. If attack is happening from bottom side, that is the back side, you will get trans product as usual. If attack is happening from back side, you will get trans product. If attack happens from the same side, you will get the cis product. Now, can you suggest some intermediate spaces, or can you suggest me the mechanism? And if you want, you can copy. And those who want to think, just think, what is the mechanism, how this progress, so that I can get the two product. You have to also think about pH. This pH will, what this pH can do. This pH can give electron and it can basically stabilize some species, and that's enough hint you can have. Okay, if you have written, then I can clearly say, since attack is from both sides, this suggests me intermediate should be a carbocation. This time intermediate should not be a cyclic intermediate. This time this should be open intermediate, and this is a carbocation. This is not cyclic halogen ion. I am getting intermediate. In this case, intermediate must be carbocation. So I know, because the experimental effect cis and trans, intermediate must be carbocation. Are you getting or not? So in this case carbocation is intermediate, and let us see and why we are getting carbocation, you will soon understand. So you have here pH group. Oh my god. So this is here, there is a pH double bond, Now this Cl, so first step is very usual. So you have lone pair here. So one lone pair more. So this goes here and this goes here. If this happens, so I can write, are you able to see or not? So this is chlorine and this is arrow. So you will have this pH here. Now this chlorine here. Now you make a carbocation, full-fledged carbocation. Now this carbocation is resonance stabilized, and that's why in this case I am making the carbocation, not making the carbonium, halonium ion. So this ion we are not making, that cyclic intermediate not forming. This is a open intermediate, open chain intermediate, not cyclic. Open chain intermediate, you can say. Open chain intermediate. Why this open chain intermediate this forms in this case is very often can be satisfied using relating the resonating structure. You see in this case you have a pH group here, are you getting or not? And here you have a plus charge, here you have a chlorine. So now this plus charge is basically resonance stabilized by the ring. So this species, this carbocation is resonance stabilized, and that's why we are getting a carbocation, resonance stabilized. Now if this is resonance stabilized, carbocation is formed, and once this carbocation is formed, you can attack from this side or you can attack from the bottom side. So if you attack from the top side, you will have one isomer. If you attack from the bottom side, you will have another isomer. Are you getting or not? So let us say, if I say this chlorine is front side and hydrogen is back side, if attack happens from this side, you will have one isomer. And if your attack happens from the bottom side, I can show you the same thing in a good way, something like this. So let us say I have a pH group here and I have a chlorine here. Are you getting? And there is a hydrogen, and this is the carbocation I have. Now if attack happens from the top side, you can have both attack. So if attack happens from the top side, pH, you will have Cl, and here you have Cl. Hydrogen, hydrogen, you will get the trans product. Now if attack happens from bottom side, you will have cis product. pH is here, Cl is here, and Cl is here. So in this case attack happens, oh my god, I have to put this Cl here. So this is hydrogen. So if attack happens from the bottom side, you will get the cis product. So in this case you will get this cis and this is the trans. Are you getting or not? Let us copy this fast. So this is an easy problem basically. Only thing you have to understand is in this case the cyclic halonium ion is not an intermediate. In this case open chain carbocation is full-fledged open chain carbocation is intermediate, and that can be basically attacked by on the top attack. It can also attack from the bottom. Why this carbocation is formed? Why not cyclic halonium ion is formed? This can be visualized using the resonance theory. You see, due to the resonance, this molecule gets stabilized. This carbocation gets stabilized due to the pH resonance, because pH is stabilized. So this is a benzylic carbocation, pH CH plus. So this is even tertiary carbocation also. You see 1, 2, 3. So this carbocation is very stable. This is because the tertiary carbocation you have. Are you getting or not? So this carbocation is a tertiary carbocation because this is carbon is tertiary, as well as benzylic also. So tertiary benzylic, very stable. No need to form a cyclic intermediate. It can easily form a open chain carbocation because of the stability. We'll discuss the next problem. I think all of you have copied this one. Things are easy.